Hi everybody. My name is Fabrice Bernhard, and I'm really pleased to be here to, to talk to you about modernization of legacy PHP application using Symfony2. It feels more like preaching, which is really cool. So if I've come to actually submit this talk to this conference in the first place, it's because I've come to think that it's never been a more actual topic than now. So as the CTO of Symfony2 is a team of web experts based in Paris, working primarily with PHP and Symfony2. I've come to observe that more and more clients are coming with legacy applications that they want to modernize in a way or another. And it's a really interesting and with a lot of added value topic. So I'll first try to convince you that this is a really important topic and convince you that the good solution to tackle the problem is to do progressive rewrite. Then I'll try to go through all the technical challenges that you face when you try to do it in a progressive way and the solutions that we found at Theodo. And then I'll try to briefly conclude about the future and what can still be done on this topic. So the first thing is I think we all know here that there are many, many legacy PHP applications everywhere. To be a bit more precise, I try to find some numbers. So they're debatable numbers, but w3text.com says that 79% of the websites among the top 1 million websites are in PHP, which makes a lot of websites. And many of these websites and web applications have been written in a period that I call the web spaghetti age, which is between the start of PHP, which is 1994, and which I consider to end finally in 2007 when the two first really good MVC frameworks came out, which are Zane framework and Symfony2 in the stable version. So you have 13 years of PHP apps that have been written in mostly what we usually call a spaghetti way. So that makes a lot of applications. And many of these applications are actually useful, and some businesses rely on these apps. So usually, when developers realize that a business is actually making money with like a crappy application with a spaghetti code inside, we as developers, we usually say, wow, how can this business be so stupid and rely on this really shitty piece of code? I'm sure they will die because of that. And well, most of the time they actually are making money out of it, and which is good for them. So does that mean that we developers are wrong when we say that? So I would say developers are never wrong. So, so yeah, of course there's a truth inside, but let's take some distance and not judge only the quality of the code from an aesthetic point of view, but let's try to find the business reason why this is actually bad to have a badly coded architecture application. Well, the thing is, these businesses have been able to rely on these applications for a long time and actually make profit out of them. But what brings them to actually want to modernize them, they also feel the need for that, is that they need to evolve. And I was in a business conference recently where somebody said something quite well, so I'm quoting him. So anonymous guy, because I don't remember his name, said, before the big used to eat the small, and nowadays in the new economy, it's the fast who eat the slow. So what is really bad about spaghetti code is that it's usually code that is really hard to make, on which you can make evolutions in a fast way. So this means that the businesses that are not able to change the assets in a more flexible way will most certainly be lose competitiveness and be how do you say that? Well, some competitors will be faster than them, and that will be really bad for the businesses. So what they lack is a well-designed, decoupled tested, this is a really important part, architecture that will help them bring the flexibility of evolution and be as fast as these amazing startups that you see in the United States, like Etsy or Netflix or Flickr, which do 10 releases a day of new features, when some companies I've seen are more around once every month, once every 2 months. And that is, of course, like a real handicap. So when people usually, I mean, I've seen many developers say, yeah, you're right, we need to like change this. Let's just, trash all this shitty code somewhere and write everything new and shiny again from scratch. Now that seems like a really nice thing from a developer's point of view, obviously. The thing is, I believe it's really dangerous for the business side. So there are many reasons for that. The first one is that, of course, while you're rewriting everything from scratch, while the legacy application is in production, you're actually doing a lot of development which is invisible. So you're basically going back to the pre-agile age, where it was a tunnel effect. You're writing code and nobody sees what it's actually doing. So this is really bad. You also need twice more developers because, to be pragmatic, the legacy application which is in production still needs to be maintained. You have like some urgent evolutions which are slow to do, so you need some people to do them. So you actually end up having two teams. The one team which is maintaining the old application, one team which is working on the rewrite. Also something really interesting which you tend to see when you have some experience on the topic is that people come and say, well, for example, a recent client, well, my business is like organizing conferences. So I have an application, it's quite simple. People log in, put some information about themselves, say I'm going to go to this conference, and then they can check who's also going and try to like organize meetups. Now, when you hear that, you're like, oh, wow, that's an application, people log in, they like fill a form. Wow, that's like, I can rewrite that in 2 weeks. And then 6 months later, you're still like battling against all the really strange business specialties that this guy has been developing for 6 years. Because this application that you thought was like as simple enough that you could rewrite it in only 2 weeks. There's a reason why the developers spend 6 years doing it beforehand, because there's a lot of logic inside. Of course, there's a lot of crappy logic, but there's also a lot of useful logic. And so when you're rewriting from scratch, the probability of forgetting important features is really high, which makes, of course, the transition, once you've finished your rewrite, or at least you think you've finished it, the transition migrating from the old system to the new system is really dangerous and really costly, because all of a sudden you're impacting everything your business relies on. And you know how it is. Either you try and then you realize you're missing half of the features, come back, or you try to correct them at the last minute. But it's a really dangerous thing. So, okay, rewriting from scratch is dangerous. So, of course, the solution is doing something in a progressive way, progressive rewrite. Why isn't everybody doing progressive rewrite? Well, there are, I think, two main reasons. One, it's painful, and it's technically really challenging. It's painful because you have to work with hard to read code that you didn't write, the usual what the fuck measure of seeing all these crappy things that you can't even think somebody ever wrote. And of course, also you're not only attacking the source code, you're attacking everything that the system is relying on. So you've got the source code, but the system, the environment, the servers, the data, the cache. Then you discover, oh wow, there was a caching system, and I need to also rewrite that in a progressive way. The remote web services, everything in the system will be impacted if you try to make them evolve in a progressive way, which makes it really hard. And actually, from a really abstract conceptual point of view, it's interesting to note that the challenges that you are trying to attack when you're doing a progressive rewrite are really like the ones that you are attacking when you're doing scaling, because you are trying to decouple things. to like isolate some modules that you will rewrite, just like in scaling when you're trying to decouple things and isolate some parts of your application on a different servers. So let's sum this up with a small graph. So imagine you are considering the application and the number of functionalities over time. So you have your legacy application there. It's stable because you're unable to add new functionalities. And you think, okay, now let's rewrite it from scratch. And that's what you hope for. You're like, okay, it's going to be a linear process, fast, and at some point in time, as short as possible, I will have reached the point where I have the same set of functionality as the legacy, and I can switch to the new one. Now, as I told you, like the usual truth is that it takes much more time, that you have no new features for months, and you have 2 apps to maintain. Now, the progressive way, when it works, looks more like this. You have to invest some time in the beginning, but really quickly, you are putting new features in production. You're testing it. You're agile again, and you have everything. You benefit from everything that agility brings, which is lower regression risks, and of course, unbeatable time to market. Here, I can use my laser pointer. Here you see that the first functionalities can really come out really fast, and that's experience. We've managed to do that, and that's quite impressive for the business side. Even if from the developer side he's got the impression to have somehow just done a few things in the spaghetti code, it really brings something to the business. So let's go now to the technical aspects of it and go a bit deeper. So we started working on these aspects of rewriting in a progressive way this year at Theodo. It's an R&D project, and the aim is to solve all the issues of progressive rewriting to make it easy and agile again. And of course, this is also a way to help Symfony2 take over the world, because Theodo Evolution is not only about agile rewriting, it's about agile rewriting to Symfony2. So the people who've been working on the project, most of them are here on the pictures. I'm not showing the pictures to make them happy, to see their faces, because I'm also showing the pictures because most of them are here today, so you can ask them questions, especially because some of them know more about some technical aspects than I do. So I might use them at the end of the talk to answer your questions. So let's go through the big picture of the different technical aspects that we've identified as being challenging when you're doing progressive rewrite. So the first aspect is preventing regressions. Yeah, you want to somehow reassure yourself that by touching your tightly coupled legacy application, you're not breaking everything. Then, of course, you will need to upgrade the system, because most of the time your legacy application is on a system that is not compatible with Symfony2. So, then you will have the routing aspect that was also briefly discussed yesterday in the Easy Publish presentation. So how to say, okay, this request goes to the legacy application, this request goes to the new version. Then there's the layout that you want to share. You want your rewrite to be transparent for the end user. So you want to somehow share the same layout, the same visual aspects. Then you want to share the session, the authentication system, so that the people don't have, to log in twice. And then you're attacking the 2 most difficult aspects, which are decoupling the code, isolating modules, so you can really rewrite them and trash them bits by bits, and migrating the model and the data, which is the last one because it's the hardest one. So preventing regressions. So the idea is you will have to put as many securities around your application as you can, and that it will still not be enough. So that's why I wanted to illustrate it with belt and straps. Unfortunately, the legacy application usually doesn't look as sexy as the person in the belt and straps. So how do you do that? Well, of course, you do functional testing. Yeah, the problem is, of course, I briefly mentioned it, but why is it really important to test? It's because spaghetti code, by definition, is tightly coupled code. Tightly coupled code means when you're touching something, you're breaking everything. And usually not in places you would expect it. So even if you are testing manually, really, like in a really serious way, you might not test in the right way, in the right part, because you think, I touched this, this has impact here, let's test here, and actually you broke it in the other end. The problem is, well, creating functional tests after you finish the development is usually a huge investment of time, and it's not even always that useful. So my recommendation on that part would be to create functional tests on the most critical scenarios, the ones that would harm your business. I don't know, like the usual buying tunnel and things like this. And it's the really interesting bundle that you have in the Symfony2 community is Mink. Mink is it's been written by the same guy who wrote Bhat. It's an abstraction layer for all the functional testing systems that you find in the Symfony2 community, which are good, the HTTP layer functional testing, or Zombie.js, which is a headless WebKit, or Selenium, so that you can even test in Internet Explorer and things like this. I like that because you want to do functional testing, and then depending on where you are in the application, you might want to do it with JavaScript enabled or not. You want to do it with Internet Explorer, or you know you don't need to test it on Internet Explorer. And at least you have like one same set of code for all these technologies behind. Now, to be really pragmatic, functional testing is nice, and it's okay, you're testing like the most critical aspects, but the truth is you're never testing the small subtleties of like your big, huge legacy application. And the most thorough way to functionally test it is to put it in production. So let's be pragmatic about it and make it possible to react quickly when there's a problem in production. So of course you need to have a strategy of monitoring strategy and a strategy of deploying often and small updates. This is all, you know, things which are also recommended by the whole DevOps movement. You have to set up a fast rollback system. You're putting something into production, everything breaks, you push a button, it comes back. And you have to set up a really fast deployment system, because it's actually more interesting usually to correct it when there's like a small correction to make and put it in production in 3 minutes or in the minute than to try to roll back everything. And you need to do it in a nice way. These are all really interesting aspects which are not directly connected to Symfony2. So I'm not dwelling too much on the technical aspects, but I don't know if we're supposed to answer questions during the talk. Well, we'll wait at the end, I'd say. But these are aspects where you will look at technologies like Fabric or Capistrano and of course Puppet and Chef to set up your environments. So now comes the interesting part, upgrading the system. So if you want to do Symfony2, which is the whole goal of this, you need a PHP 5.3.3 minimum. And usually your legacy system is 5.2. So there's an interesting part to it, is that usually if you say to the business side, oh, I'm going to invest 1 week in trying to migrate your legacy system to a new system, and the guy asks, what for? So I can then install Symfony2. Yeah, and what's my business benefit? Well, in the long term, blah, blah, blah. Now, the good thing is usually when you migrate to PHP 5.3 or 5.4, you get also huge performance improvements. So at least you can put it in a better way. Like, yeah, I'm migrating everything, and we'll surely get 30% performance improvements in the same time. So business is happy. There's a really nice script called, the check PHP script that checks if your system is compatible. That is quite interesting. Now, if your system becomes compatible with Symfony2, it might actually become incompatible with the legacy code. So this is this is another problem. There are really nice code sniffs for PHP code sniffer that are able to check your legacy code and identify all the deprecated functions it's using, and so you can rewrite them. And of course, the best way is to set up the pre-production environment and just test your whole legacy system on it. And if it works, run your functional tests, because by that time you've written many great functional tests. And of course, take the time at that point to provision your environment this time. I'm saying this time because usually legacy systems are not described by Puppet manifest. There's an interesting library that I'm mentioning here, Blueprint, which is a good way to start with Puppet, which would text your legacy system and creates manifests automatically. So they're not really nice ones, but at least it's a way to start. Okay, let's go to the code now. So the first part is you want to put your legacy application and the new one you're developing and in the same place and route depending on the request. So the beauty of PHP is that usually when you see legacy applications, they don't even have routing. That's amazing. There was a time when routing was not useful. So you've got different ways to separate your new and old applications. So the easy way is, just identify by different subdomains or by a subfolder. Try to keep the same domain because that will make everything easier for the cookie and session things. It's not my preferred way because I think in the long term you get some drawbacks out of this. And they're not even beautiful. I mean, who wants to go on v2.yourapp.com? So it's not that nice. So my favorite is to handle it with Symfony2. So this is a pedagogical example with a catch-all root that matches any filename.php root, and it goes to some Symfony2 action that simply starts output buffering, includes the file name, and return the response. Well, in the real life, it's a bit more complicated, but it works. So it's really interesting. And in this way, you also get the enormous benefits of having access to everything Symfony2 in your legacy application. So if you need to correct some small bug and you want to use some Symfony2 library, this enables you to do it. So it's really interesting. What did I want to say? Oh, that's it. Yeah, just something. Somebody pointed to me that instead of doing some catch-all route, I could use a chain routing bundle. So yeah, I share with you this really interesting information, which is not done here. From the other way around, for example, if you're migrating Symfony1 to Symfony2, or if you're migrating any legacy application that does have a routing system, you might want to have access to it to be able to include the URLs generated by the legacy routing system in your new templates. So for example, for Symfony1, it's quite easy. You just do a twig extension that you call, and you create a new function called URL4 that goes into the Symfony1 code. It's not really complicated, so I didn't put too much code here. I just pointed out that this small hint, that you should put the no script name to true, because if you don't, he might, the routing system legacy, I'm saying it might actually generate routes with app.php instead of index.php or things like that. So we created a nice bundle at Theodo to do that, and it was too big to fit on the slide. Okay, so now you have two applications, one next to one another, and at least it's working under the same domain. So the thing is, now you have to share the layout, because progressive rewrite for end users is basically the same template. It's the same template saying, wow, it's transparent. I don't see that it's the new and the old. So that's like I think the first priority you have to handle. So one way to do it is to copy-paste the layout, which is of course not a good solution because layout is a menu. So this means that every time you change the menu on one side, you have to change it on the other side. So of course it's a source of really big problems. The solution we opted for, which is really interesting, is to use ESIs, edge sign includes, which are basically iframes which are merged at the reverse proxy level. So what are we good? This would be a Symfony2 template, and it says get the content of the menu from this route and get the bottom of this of the layout from this route. And this way, if it's, for example, if you can cache, I mean, the whole caching thing is done directly by your reverse proxy, Varnish, for example. So it's an easy way to solve this not so easy problem. And that would be somehow the way what you have behind behind these routes, which would be an action that crawls in your legacy application. You take a page that is fast to load, and you just download the content, and then you using Gut here, you get the content. Since if your menu, for example, depends on the users, then you have to not forget to pass on the authorization headers and the cookies. And here's the important trick: you have to stop the session before you start crawling, and this way you're able to get the content automatically. Then you cut it in pieces, and you take only the menu and give it back. And since you have ESIs in front, you can cache it, and so it's actually not making so much of an overhead. Okay, now you have two applications, same domain, same layout. Nice. Now you have to share the session and the authentication system. So the session is accessible. If you want to make the session accessible from within Symfony2, the small problem is that Symfony2 expects the session information to be neatly stored in like one attribute, one namespace, and in arrays. Really nice, which is usually not the case of your legacy session. So, but it's not so hard to circumvent. Basically, you just have to register bags for each of your legacy session keys, and if some of the information you have is not an array, then you have to create a new type. We created what we call the scalar bag to solve this. So this would be an example to access the credentials and the attributes of a Symfony1 session. So basically, you just have to create namespace attribute bags and register them. Not so complicated. And you put it, I don't know, on the kernel request event. So then, imagine you want to go further than just accessing the session from within Symfony2, but you want to share the authentication system. So of course, this depends on how your authentication system works. If it's with Symfony1, we created a great bundle for that. And I was looking at it and trying to find some pieces of code that were really interesting and I could put on the slide. And then I realized that first, I didn't work enough on it to find the nice pieces. And second, it was too big to fit on the slide. So instead, I put the pictures of the guys who did it. So these guys are somewhere there. And they're laughing right now. So you can go to them if you're interested by this topic. And if you want to discuss this with them. So now you have two apps. You can make new evolutions. It's transparent for the end users because it's sharing the layout, it's sharing the session, it's sharing the authentication system. Nice. So now you can really easily create, and this can be done really quickly, all these steps. You can create new evolutions on your legacy application without a problem. Now the problem is usually you don't want just to make new evolutions, you also want to rewrite some parts because they're really slow or they're, I don't know, badly architectured anyway. So this becomes more complicated. You're attacking the spaghetti problem. So, nice spaghettis. This is when it starts to be less like technical hints and more like methodology. So what you wish you could do is have this kind of architecture, because if you had like many spaghetti modules that were loosely coupled, you could rewrite them one by one in really nice, clean code using the Theodo conventions. Yeah, if you don't recognize, this is the Theodo logo. This is like the metaphor for great code. And you rewrite it bits by bits, and then wow, you've got this amazing, newly written application that is almost as good as if Theodo had done it itself. But for that you would need this kind of dream architecture. And unfortunately, what you usually find looks more like this, more like a complete graph, when you are good enough to actually identify the graph, because usually it looks more from the outside like a big ball. So what do you do when you somehow manage to find like different modules, but you see how many coupling they have between each other? Well, the solution is to actually create the dream API you wished had existed in the first place, and slowly refactor using TDD, test-driven development, around it, and like slowly, some couplings disappear, and you have this much nicer architecture. And usually a good way to do that, and there are many really interesting books about that, is to do test-driven development, because you're testing around the API you would like to have, and this is a good way to refactor code. I think a good presentation needs a Wikipedia definition. So here's the Wikipedia definition of the design pattern that I was actually showing here, which is called the facade pattern. So basically, a facade is an object that provides a simplified interface to a larger body of code. So it can do many things. The most interesting one in our context is the third one, which is reduce dependencies of outside code on the inner workings of a library. So this is the way to go. This is of course a lot of work, and this is not that easy. The interesting thing about Symfony2 is that it actually provides a way to do it really nicely, which is a service container. Because the new API that you want to do in your facade pattern will be a service. So basically, you would create a bundle for every module you identified in the code. And then for every bundle you would create a service that would be used as a gateway to this, batch of code as your facade API. And then you refactor your code slowly using the services that you created. And this is a nice way to go. And then at the end you have like really beautiful code in Symfony2, like in nice bundles with nice services loosely coupled. Great, now you have nice code and everything, but there's still a big problem of migrating the model and the data, because if you happen to... So sometimes the model is not that bad, which is good. If it is, it's really complicated, because as much as the code seems tightly coupled, the database is usually much more. This is like a typical Symfony 1 database I graphed with DB Visualizer. And so you see that every table is connected to at least, 5 or 6 different other tables, which means that a module that relies on a table basically relies indirectly, because of the relational aspect of the database, to 5, 6 other tables which are in different other modules. So trying to somehow isolate parts of the model and try to cut the model in pieces to rewrite some aspects of the model, I feel like trying to cut this guy in pieces. So I'm really happy to have found this guy on the internet, because this is exactly what I had in mind when I was thinking about attacking the model. So what do you do in that case? Because it's really impossible. Most of the people, classical solution is to say, okay, let's just have the old model and the new model. So we have 2 versions of the data, and we'll try to make them coexist. So what you do is you do a copy of your database, then you set up somehow some synchronization system, and then of course you improve your model to something much more sexy. It looks more like this. Because that's the whole goal of trying to rewrite it, and the new application will work in the new model, and the old application will work in the old model. So syncing can be done with ETL tools like Kettle. Kettle is quite nice. It's like a Java tool. It even has like a graphical user interface, and it does streaming. So you can somehow give rules of how to convert your data from one model to another, and it streams, so even if the table is really big, it works quite fast. Or you can do custom code in your application. In all cases, this is a really complicated problem that brings you a lot of headaches and horrible bugs that corrupt your data. I would say to avoid the unbearable headaches, just try to write in only one database. Which means that you spend some time rewriting in the legacy application the parts that create, edit, update, and delete data, and to try to make them go to the new database. It's a bit like scaling once again. You have this master database you're writing in, and then you have the multiple database you're reading from. So this would be like your typical bearable headache solution, where you have the legacy application writing in the new model and reading from the old one, so you don't have to rewrite all the reading parts, and your new application is using the new model, is really happy about it. You've got your routing, choosing between one or the other, and you've got your magical ETL solution. This is the hardest part, that brings the data from one place to the other. To be more pragmatic, I would say if your legacy application is MySQL, and it might be a good idea to actually try to use MongoDB in the new version, because once again, it's just like scaling. Non-relational databases are much easier to maintain and to do partial evolutions on, because they're less coupled between the tables. And also the really interesting part about a database like MongoDB is that since it's a document database, you can have in the same collection data which coexist in different versions. So you can, and what you do in that case is, for example, use the really nice Doctrine ODM preload annotation to migrate just in time. So before loading the data, you check, oh, is it like the old version or the new version? And if it's the old version, you rewrite it, you save it, and you give it to the application. So this way you can do what I call just-in-time migration, which is quite interesting. So now, as you've seen, the solutions are all magical, but we've, I think, tackled all the interesting aspects of progressive rewrite. So what does the future look like? So at Theodo, we are today 18 and growing, excellent web developers, and we're currently working on 6 progressive rewrites of huge applications to Symfony2. So we're really collecting interesting experience on these aspects. And what we're trying to do is that every innovative and interesting technical solution that we're finding, we're trying to bundle them in our project that we call Theodo Evolution. And the goal is to somehow make it an out-of-the-box solution that would enable to work on legacy applications, but without touching the legacy code. So you've maybe heard in my presentation that at some point we were touching the legacy code, which is always painful. And the goal is to really, as much as possible, get out of that. And of course, that way convert the whole PHP world to Symfony2. And this is not written here, but in the long term, convert the whole world, web world, to Symfony2, because some of these IDs could actually be used on different technologies, as long as the routing is done before you enter the technology. So how can you profit from Theodo Evolution? Well, first there's this really nice presentation that you will be able to find on the internet. Some of our bundles will be open sourced. This is, I can't promise an exact calendar yet, but some of it will be open sourced. And in the meantime, what you can do is use our massive presence here to ask questions to the guys that worked on these aspects. So you can recognize them because they're wearing these really cool hoodies, and most of them are here. And of course, you can contact us. My Twitter is Theodo, and my email is here, Fabrice Bernhard, exactly. So thank you very much for listening to me. If you have any questions, feel free to ask them now, and you can even make feedback on Joined In here. Thank you very much. So now it's question time. You still have your question?
Yeah, wait, I have a microphone for you. Was it you? Yeah.
My question was just about what tools you were using for deployment, and you just said afterwards Fabric and other tools, so I think it
well, it's an interesting aspect, so I can just go a little more on this. It's the critical part, actually, of, I would say, a web project, because the ease of deploying is really what makes a difference between the really good startups and the old style. That makes a difference between the really cool startups and the old-fashioned companies. So I'm using Fabric a lot. I think I like it very much because I also like Python. And for provisioning, it really depends. For the moment, there's no technology that is, I think, better than the other. Puppet and Chef are both really interesting. And actually, for like simple use cases, we're using a library called FabTools that goes on top of Fabric, that enables you to provision really like 2, 3, 4 lines of Python your server. And the really cool part about provisioning a server is that it makes you, it's really much easier to then upgrade your system later on. It's really useful if you want to react to some crisis. I mean, the server crashed and burnt, then at least you have a way to buy a new server on Amazon and in 5 minutes have the new system running, if the backup worked well, of course. And you have also this really interesting cloud pattern of, instead of trying to upgrade your system all the time, you just say, okay, let's provision a new machine. Let's buy a new machine, provision it on the new Debian version, migrate the whole system to this new machine and kill the old one. So this way, if you have whatever, some viruses or security issues on your former machine, you just kill it. It's a bit like a cellular way of doing. Really interesting.
Thank you.
Anyone else? No. You go.
What's your favorite plan to migrate Symfony 1 applications to Symfony 2? Is it, or would you consider Symfony 1 application as a legacy application, and would use the same procedure you presented, or is there a more easy way or some other way?
Well, first of all, it's not because Symfony 1 was created that the spaghetti age came to an end from in one day. So we are working on legacy applications, so we consider legacy, which are written in Symfony 1.0, and unfortunately the developers who worked on the project didn't really understand MVC at that time. So it's not because it's Symfony 1 that it's actually much better architectured. I would say that it's easier to migrate Symfony 1 to Symfony 2, especially because there's a lot of community working on these aspects. There are like blog posts. Stefan here made and was one of the first ones to make a nice bundle to do that. And so yeah, this is like a simple reason why migrating from Symfony 1 to Symfony 2 is easier. But it's not that much easier, of course, there's a lot of work.
Yeah, first it's him, then it's you over there.
Have you tried to separate the authentication to the varnish and to transfer einfach headers to both to the old and to the new application?
Okay, so if I understood well, the question was migrate the authentication to the headers.
Yes.
And this way make it easier. Well, it's an interesting idea. How easy would that be in Symfony 1? Yeah, you could actually. Yeah, the idea of what we did was to use what is already in production in the Symfony 1 system. So that's why we actually worked more on creating a Symfony 2 bundle, so that we didn't have to touch to the Symfony 1 parts. But of course, using headers is certainly like a good solution if you're working on some really crappy application and you don't want to use the authentication system anymore.
Okay, thank you.
Can you pass it over? Yeah, you said you were working on 5 progressive rewrites, but who's doing the maintenance on those projects? Because often crappy code is created by crappy programmers, so you probably don't want those programmers to do the rewrite. So who's doing the maintenance then?
Who's,
I mean on the old application, on the legacy code.
Okay, so the question is, how do we politically handle the crappy coders?
Well, yeah, but maybe you take on the legacy code as well and do all the additions and maintenance yourselves, but I don't know.
So I will just say what we're doing. So and all the applications, I'm trying to think right now, usually when we arrive, it's because the crappy coders disappeared somewhere. Because they were fed up with maintaining the application and somehow they make, I don't know, nervous breakdowns. Or actually, it's not funny because it really happened to one of the developers from which we took the application. So usually when we arrive, there's no more developers maintaining the system. So we are responsible for maintaining it, which is of course really painful. So this is why we're really motivated to work really fast on the evolution. And yeah, and in the meantime, let's say that we're working in legacy code sometimes, and that we are trying to see it in a positive way because it teaches us how we can circumvent the fact of dwelling into it. Yeah.
Okay, thank you. Anyone else? Looks good.
Thank you very much.